Good morning, everyone. Today I want to talk about a couple of things I got a chance to play with while building a test application. Now, I build test applications like this regularly, and the purpose is primarily to give myself an excuse to try out this sort of new programming stuff that I haven't used before. And additionally, it's just useful to practice programming all the time, or else I'll get especially rusty at it. And secondarily, an app might occasionally be useful, but that's not really the main purpose here. So the app that I built this time was a shopping list app. Now, this is a pretty common demo app that you would build as a simple thing to try out a new programming platform or tool, and that's what I'm doing here. But the objectives of this particular application is that I wanted to be able to have multiple named shopping lists. For example, a shopping list for groceries and a shopping list for the pet store. We want to be able to add, edit, and delete shopping lists and items. And once we've gotten an item at the store, we want to be able to cross the item off a list without actually deleting it so that we can see that we got it. And so what we have is a relatively typical test app with two interesting specific problems to solve. Problem number one is that we want to have a cross-platform app. Here's the app I ended up building. This isn't a terribly exciting app. The user interface isn't super fancy. But if I need to go to the grocery store and buy stuff to do a cookout, I can say grocery store and get a new list. I can click on the grocery store list. I can say I want hot dogs, hot dog buns. I can say I want marshmallows. And now I have those things on the list. When I get to the store, if I want to cross something off, I can do that. And the interesting feature of cross-platform sync allows me, if I have a mobile device, this is a Librem 5. So one of the neat things about the idea of using a web application to solve this problem is that it will work transparently on Linux phones. So if I show this here, it's really hard to see. So the first interesting problem that I wanted to solve is making the app cross-platform. And there's a bunch of ways that I could have done that. There are several tools that allow you to build an application and then produce native applications for multiple platforms. And that would work perfectly well for this application. But I wanted to do this as a progressive web application because that sounded like fun. And it would definitely work on Linux phones, which is something that some of the cross-platform app development tools don't necessarily give you for free. Now, the thing about a progressive web application is that you build a regular web application, and then you add a couple of pieces which will allow you to, once you've completed a regular web application, converting it to a progressive web application technically requires two things. The first thing is that you need to add some metadata in the head of the HTML document that is the main page of the application, which specifies that this is supposed to be a progressive web application, what the application icon is going to be when this is added to the home screen on mobile, and some other random stuff. And then the second thing that you need to add is a web worker, which is some JavaScript code that handles caching. And the web worker for a progressive web application, if you want to have offline support, should handle caching in such a way that the browser caches the application files and is able to pull them from cache when you access the application offline, instead of just breaking because the remote server isn't accessible. Now, in practice, I did this using the Next.js framework. That was the application framework I used to build the application. It's just a sort of batteries included web development framework for React.js. It's pretty nice. I might talk about it later, or I might not, because it's not that exciting. But Next.js has a plugin called Progressive Web Apps have some pretty clear upsides. You get to build a web application, which is sort of the most popular development platform out there at the moment. So people are comfortable building web applications, and going from a web application to a progressive web application that feels like it can be installed on mobile devices is pretty simple. Unfortunately, there are some downsides to this. And the downsides to a progressive web application are basically the downsides to a web application in general. Now, the two that I want to point out here are, first, that progressive web applications require a modern browser. And that's going to be the default browser that all users have, but modern browsers are pretty complicated platforms, and those platforms are not perfectly stable. Features in browsers do get deprecated and replaced, and that means that if you write a web application today, there's no guarantee that your web application is still going to work perfectly in a year, or definitely not in 5 years, without developer effort to make sure that you keep up with the changing platform. And I actually ran into that in trying to figure out how to set this up initially, because the way that the mechanism for managing caching on a progressive web application works has changed over the last 5 years. The old system was that you created a manifest file that would statically specify which files the browser should aggressively cache, and then it would just do the right thing automatically. And for this particular application, that would have worked perfectly. Unfortunately, that mechanism has been deprecated and no longer works in some modern browsers in favor of this web worker script mechanism where you programmatically intercept cache requests and then modify them. Now, the programmatic web worker solution is much more powerful and flexible than the manifest solution was. The manifest solution didn't do the right thing for a large variety of applications, but the fact that it was a supported mechanism previously and now is becoming unsupported is sort of the story of the browser platform. Now, browsers are real complicated, support a ton of technologies, and for most of those things, the backwards compatibility commitment is really strong. Unfortunately, the browser environment is complicated enough and is supporting enough different APIs that really we can't rely on everything being supported, and at a certain point, the best bet for dealing with the browser is going to involve strong drink. The second interesting problem I wanted to deal with here was syncing data between devices, and that runs into one of the hard problems in computer science, which is distributed data storage. The big problem with distributed data storage is that if you have data stored in two places, that means you can have concurrent updates where someone makes a change in data store A, someone makes a change in data store B at the same time, and then when those two data stores try to sync up, you get some conflict. Maybe you added hot dogs to shopping list on device A, and you added hot dogs to the shopping list on device B, but you requested 12 hot dogs on device A and 10 hot dogs on device B. And then programmatically, when you try to sync up, you figure out that hot dogs are the same thing, but you don't know whether you actually want 10 or 12 because the two users or the same user on two different devices inputted conflicting data. And there's no way for the software to fix this for us. At least there's no way for the libraries and databases to fix this for us. We have to understand what the problem that we're trying to solve is in order to know what the answer is. And in our particular case, it's not that hard a problem. We don't actually care whether the shopping list says 10 hot dogs or 12 hot dogs, because the person at the store is going to stare at the list and make their own decision anyway about how many hot dogs they really need. The important thing was the reminder to get hot dogs. Similarly, if hot dogs ends up on the list twice, that's not a big deal. But when the programmer is writing the application, they have to actually think about that conflict and answer the question of how is that conflict going to be resolved. So this is an excuse to try out a pair of tools that are specifically designed to deal with this issue of syncing data between devices, and that is CouchDB and PouchDB. Now, CouchDB, and let me pull up the website, CouchDB is a NoSQL database that stores JSON documents. And it's especially good, it's focused on distributed replication. It has a built-in sync protocol that's efficient, and the whole API and data storage mechanism here is designed assuming that there will be conflicts, and that the programmer needs to explicitly consider and resolve those conflicts at every step where that could happen. So that's anytime data is inserted into the database, there could be a conflict the programmer has to deal with, and anytime a sync occurs, there could be a conflict that the programmer has to deal with. Now, CouchDB is an Erlang application, so it works really well to run on a server or multiple servers and then have them sync to each other. But that still leaves the main problem from my shopping list app of storing data in multiple browser instances. The user-facing client application here runs in the browser, so we need to run data storage in the browser, especially since we need to support offline use. Luckily, there is a thing called PouchDB, which is a JavaScript library that implements the CouchDB data store and sync protocol. So you write JavaScript code that works with a data store that works exactly the same way as a CouchDB data store and stores that data in the browser using the local storage mechanism in the IndexedDB API to actually organize it. And PouchDB can sync directly to remote CouchDB servers. So technically for this particular application, I went ahead and installed PouchDB, and that basically solved my local data storage problem out of the box. I had to figure out how to model my data as JSON documents, and it turns out that just having every shopping list and every list item be its own JSON document, and having a type field to distinguish those two kinds of document, and having each kind of document have a consistent schema. We can see over here that a shopping list is basically just a title, and a list item is a name, account, and a note. That's the whole schema for this application. That schema works fine. That's what the JSON documents are. So once I installed PouchDB and figured out that schema, local data storage in the browser worked. Now, because we're working with the CouchDB data model, that requires thinking about and resolving update conflicts on every insert. And in this particular case, if I have two different conflicting versions, I take an arbitrary version, pick the left one no matter what, and that's fine for this application. The only thing that's running on the server in this application at all is a CouchDB server. There is no application server for the shopping list program. And syncing to the CouchDB server is pretty straightforward. We attempt to sync every time the local data is updated, and if we can't connect to the remote server, we throw away the error. And that means that every time you make a change, it syncs to the server, but every time a change happens on the server, that doesn't get pushed out to the client app, the code running in the browser. It would be nice to push remote changes, and that would be pretty easy to do if we had an application server using WebSockets or something. But that would require adding an application server, and an application server isn't relevant to the things that I'm playing with here. I'm trying to play with CouchDB, PouchDB, and progressive web apps. So I didn't bother adding an application server. Instead, there's a big sync button in the top of the UI, and if you press the sync button, it will attempt to sync. And that works fine in this particular case. The trickiest part of setting up the CouchDB server was authentication. Users and permissions need to be set up manually, and the authentication on the sync requests is HTTP basic authentication. Because we're connecting from the browser to the server using HTTPS, that's reasonably secure, but it would be difficult to expand this to a more complicated security model where we sort of had a large number of untrusted users. So does this work? Yes. We're able to store data locally in the browser and on the server. Syncing works exactly as expected. With a single central CouchDB server, we can sync any number of devices for any number of users. Users in this application are CouchDB users, and so that's fine. We have a set of shopping lists, a CouchDB database. A user is a CouchDB user. We can have multiple users who have access to a database. While they're a user, they have unlimited access. If we need to revoke someone's access to the set of shopping lists, we remove their CouchDB user. Wonderful. What are the advantages of CouchDB and PouchDB? PouchDB provides a document store in the browser that works great out of the box. That's nice. It has the issue of resolving conflicts is upfront in the API. The programmer has to deal with it. There's no way to write a version of the app that ignores it and then run into trouble later. So that's wonderful. PouchDB syncs nicely to CouchDB, and CouchDB also handles these replication issues efficiently and potentially correctly, as long as you write your code to resolve conflicts correctly. So what are the downsides of this system? So in this particular test application, we're actually accessing the CouchDB server directly from the browser, and we're using CouchDB users as app users, as I mentioned previously. For an application with like a bunch of untrusted users on the internet, or even a large number of users internally in an organization, this may not be an optimal solution. And I'm not entirely sure what the best way to take advantage of the CouchDB sync protocol is without doing that. It clearly isn't impossible, but it would require some more design work in order to figure out how to do it. And in order to take advantage of the CouchDB protocol, there does have to be some mechanism where the browser is connecting directly to the CouchDB server. I can't put an app server in the middle for that sync step. Now, there's a couple other problems here with CouchDB that I actually think are kind of ugly. They have two sketchy issues with maintenance of the CouchDB application itself. The first problem that I have is the smaller problem, and that is that they don't start supporting new Linux distribution versions until after those versions release. So if we get like an Ubuntu LTS release or a Debian stable release, the CouchDB developers don't have a release for CouchDB available when those ship. They start porting to the new version when the new version ships. And in the case of me writing this test application, that meant that I had upgraded most of my stuff to Debian Bullseye, and I completed this application before CouchDB support was released for Debian Bullseye. So that meant I needed to come up with a server with Debian Old Stable on it in order to host CouchDB effectively here. And the reason why that's a mess is because the whole idea of long-term support stable Linux distributions is that the distribution is providing a support window to the people running the server. And so if you have Ubuntu LTS or Debian stable, you're going to get a solid 2 years when that is the current stable version. And then you get a further 2 years or so where that is a supported old stable version. When vendors like CouchDB start waiting to ship their application until the LTS distro is actually released, they're cutting into the end user's support period. And in this case, CouchDB managed to ship about 2 months later. That's not great, it's not terrible, but they should really work on taking advantage of the beta period for these distributions, since that's what the beta period is for, to prep apps. Now, the other issue is even worse. And that is that CouchDB still uses the MD5 hashing algorithm as a stable hash for identifying attachments. Now, MD5 was developed as a secure hashing algorithm long ago, and it was determined to be broken in around 2004. Now, the period when you could argue about how broken MD5 was from maybe 2004 to 2009. But after 2009, there was no excuse to be doing anything with MD5 except for scrambling away from it as quickly as you possibly could. Any use of MD5 for anything whatsoever in 2021 is a sign that the developers don't take security seriously. Some developers like to make excuses about broken cryptographic hashes and non-cryptographic contexts using MD5 as a stable hash. They're claiming that that is a non-cryptographic, non-security critical use case, but very simply, all of those excuses are bullshit. You don't use cryptographic primitives that are broken at all. No excuses, you just don't do it. So in conclusion, CouchDB is really neat, but I can't recommend selecting it for production use without carefully evaluating, especially that MD5 issue. The way it's used could result in some edge case security issue involving user-supplied attachments, or there could be some worse problem hiding in there that this is the warning sign for, that you want to like triple check that CouchDB is reasonably secure and it's secure for your app the way it's going to be used. If you have security properties that you want to guarantee, this use of MD5 could break those security properties. Thank you for watching this video. Go ahead and click the links in the description to get to my blog where you can subscribe to the RSS feed so you don't miss anything that I post. And you can get to the blog post about this particular video, which will include some links to sources and stuff. Have a wonderful rest of your day.